answer some examples concerning the differentiation or differential calculus. So before I answer these questions, there are just a few things that you need to know. These are the formulas for the derivative of trigonometric ratios. So these formulas, you need to know them. They are very, very important. So we are finding now the dy dx of the trigonometric ratios. Let's say you have been given y being equal to sine x, and then you want to find the derivative of sine x. So the derivative of sine x is always equal to cos x. So that one should just need to keep it in mind. So like on this part here, so when you differentiate, what sine x need to have? Cos x. So that's the thing that you need to know. Then the second part is, let's say you are differentiating now cos. What is cos going to be? So since sine x is equal to cos x is not equal to sine x, but rather is equal to negative sine x. So these are the things that you need to know. Don't forget about those things. So cos x is equal to negative sine x. Now what about tan? Dy dx of tan. Let's say you're finding the derivative of tan. So the derivative of tan is always equal to secant x squared. So secant x squared, that is tan. What about secant? The derivative of secant, which is sec x. This one is going to be equal to secant. Let me use c here. Secant x tan x. So that is one thing that you need to know. So this one is coming from when you use this idea of saying tan squared x plus 1 is equal to sec squared x. So that is where this one is coming from. But no need of you worrying about where this one is coming. Just wanted to show you. Just know that secant x in terms of the derivative is equal to secant x tan x. So whenever you are differentiating, let's say you have been given y being equal to secant x. So the derivative dy dx is going to be equal to secant x tan x always. What about cosecant? So the dy dx of cosecant, which is cosec x, this one is equal to negative cosecant x cotangent x. Okay, this one is equal to negative cosecant x cotangent x. So this is the rule that you're going to use when you're differentiating those questions, or these are the rules that we're going to use when differentiating these questions here. So cosecant x is equal to negative cosecant x cotangent x. What about cotangent? So the dy dx of the cotangent or cot x, this is equal to negative, let me use cosec squared x. So it's negative cosec squared x. So you need to know all these. So now let's try to answer this question. Here we are subtracting and you want to find the dy dx. Okay, remember when you're subtracting, what are you supposed to do? You find the dy dx of this one as well as the dy dx of that. So let's find dy dx. This one is going to be equal to the dy dx of x is 1, then minus the dy dx of tan x is secant squared x. So meaning to say we are done for the first part. The second part, we have two functions here. We have x as well as the cosec x. So which one are we going to use here? We're going to use product rule because we are multiplying these two. So what does product rule state? So when it comes to product rule, you need to find the derivative of the first function, and then you multiply it with the second function. Then you add again, you multiply the second function derivative, you also multiply the original function. So what I mean is, we have these two functions. We can label this function by saying let f of x be equal to x, and then g of x be equal to sec x. So by using this formula, since we are talking about or the way this question is, we need to use the product law since we are multiplying these functions. So what we are going to do, we need to find the f prime of this. So the f prime of that, I'm going to have 1. What about the g prime? The g prime of secant is secant x tangent x. So this is what we have. So applying in this formula, f of x is 1. Let me say f prime is 1. Then the g function is secant. Then plus the g prime. What is our g prime? Our g prime is secant x tan x. Then f is just x. So multiplying, what are we going to have? Divide x is going to be equal to secant x plus x secant x tan x. Now you know to say that here we have secant x as well as here secant x. So we can factorize what is common. So meaning to say here we are going to remain with 1 and here we are going to remain with x tan x. So this is going to be our final answer. What about the third question? So the third question is involving the difference law as well as the product law, because we have two functions here which are subtracting, and also two functions which are multiplying each other. So for this part here, we can see that we have two functions. So we can let f of x be equal to 2x. Then the second part, which is g of x, this one is going to be equal to cos x. That is for the first part here. What about the second part? So let me label the first part. Then this is going to be the second part. For the second part, we are going to let f of x be equal to 2 and g of x be equal to sin x. So let's deal with the first part. What is our f prime? Remember the formula? For this part, what formula are you supposed to use? Since there we are dealing with the product law, so we need to find the f prime, then multiplying with the original function of g, then add, plus we need to find the prime of g function and multiply with the original function of f. That is for this part only. Even for the second part, we are going to do the same. This is for the first part. For the second part, we are going to do the same thing. We need to find what g prime is. Let me say f prime is. Then multiply with the g function, the original function, plus the g prime, multiply with the original function of g. Let me say of f. Then see what we are going to have. So I think I can lab this part now. Okay. Now let's find the values. So we are starting with this. So what is our f of x? Our f of x there is 2. Then multiply by the g function. G function is cos x. Then plus the g prime. So in this case, we are finding sine. What is the derivative of sine? It is cos x. So cos x, then open bracket, f of x. What is our f of x? In this case, f of x is 2x. So here I can multiply. Then 2x cos x. So this is what we have. Now, let's come back to the second part here. Remember, here we have a negative. So that negative, you need to make sure that you don't forget about it. So using the same formula, the f prime multiplied by the g function, original g function, the g prime multiplied by the f of x function. So what is our f prime here? It is 0. Then multiplied by the g function. Remember, the derivative of a constant number is 0. Then plus the g function. G function is sine. Oh, sorry for this one. Made a mistake here. Not supposed to do that. We are finding the derivative of cos. So what is the derivative of cos? The derivative of cos is negative sign. Okay, so negative sign, then multiply by the g function. Let me say f function. F function in this case is 2x. So this is what we were supposed to have here. Sorry for that. So positive multiplied by negative is negative. Let me start with 2. So it's negative 2x and then sine x. So this is what we have on this part. Now in the second part we are finding the derivative of sine. So the derivative of sine is cos. Then what is f of x? F of x is 2. So this is 0. So we just have 2x. Then we say 2 cos x as our value. So this is the one now that we are going to insert on this part. So let's write now the values that we have. dy dx is going to be equal to, the first part we have 2 cos x, and then minus 2x sine x minus, so open bracket, this is positive 2 cos x. Okay, so from there we can see that here we're just going to have negative 2 cos x, and this is positive 2 cos x, so these, they can cancel each other. As a result, we are going to remain with negative 2x sine x. So this one is going to be our final answer.